Welcome to modern Qt development with software containers for devices. Shortly about me, my name is Stefan Eichenberger and I work as field application engineer for Toradex. I have an embedded background, that means I worked with a lot of embedded processors like Cortex M4s and Cortex A. And in my previous job, I also worked a little bit with Qt. That's why I have some Qt experience. However, I'm not a Qt expert. This talk is about containers and how you develop with them. My colleague Walter always introduces containers with real-world containers. For people who are not familiar with them, containers are boxes used to ship goods from one country to another, and it's a standardized way on how you can pack stuff. So it doesn't depend if you ship rice or cars, it's always the same box and the same size. Another good thing about containers is that it isolates the content of one container from the content of another container, so that the stuff inside the container does not mix together. The same thing is with software containers. So software containers are a way to pack different software, different libraries together and then ship them to customers or to other platforms somewhere remote. And another feature from containers are they are also useful to isolate software from each other. So if you run a container, an application in container 1 in this image and another application, let's say a web server, container 2, then the application running in container 1 cannot access the one in container 2 if you don't want to have that. If you want to allow this access, you can do that, but then you have to put holes into the container itself. There are several container technologies available today. One of the most famous one is probably Docker. Docker is heavily using containers and pushing them. Their main system is Docker Hub, and it's basically what I will talk about today a lot. However, there are other technologies there like LXD, LXC, which is even a bit older than Docker, and then Podman, which is kind of a try to replace Docker and is developed by Red Hat. If you are a desktop application developer, you maybe are more interested in packaging system more than in real container systems. So these packaging systems I list here, like Snappy and Flatpak, they also kind of use container technology to just pack software together. What that means is you can select a base operating system like Ubuntu 18.04 and then develop your application on top of that. And if you ship that to a Fedora Linux, it will still use the root file system of the Ubuntu system. For that, you can use Snappy, Flatpak, and so on. It makes your application independent of the base system. What is the difference between a traditional approach when you develop or write an application compared to the container approach? The traditional approach just runs an application on top of the host system, so it uses the same libraries, it uses the same mount points and so on as the host system. That also means if the application starts, it will inherit the C groups and namespaces of the calling application. You can of course change that, but by default it will just inherit. So that means you kind of have not a security issue, but it is by default it will not make your application run in a safe mode. And compared to containers, when you run a application inside a container, then the container will use the root file system of the container system, so you can pack in there other stuff, and you can even use other operating system then on the host system. So if you run on the host system, let's say an embedded distro, you can run in the container a real big desktop distribution like Ubuntu. The other thing that is nice, and that's the isolation part that I was talking about in the previous slides. By default, if you start a container, it will start this container in a different namespace, and it will start it with different C groups, so that you have kind of an isolation, so that the container, for example, doesn't see the processes of the host system. And of course, it also uses other mount points, because it even needs a different root file system. So if you do an ls root, then you would just see the content of your container root file system and not the one of your host system. What does this mean if you want to develop now with containers? So normally you have the setup. If you develop with devices, you have a developer PC and a target device, an embedded system in this case, but this could also be a server if you are developing for a server infrastructure. On the developer PC, you run Qt Creator in this example, and Qt Creator then needs some tools for debugging, to start the application on the remote system. And what is necessary is, for example, SSH to control the device, and then also GTB for debugging. And some other tools are rsync to synchronize the files between the host and the target system. The problem with Qt Creator today is that it doesn't allow to run containers directly. So what you normally need to do now is to write some wrapper script which basically abstract the underlying commands. So if you run qmake, it will not directly call qmake, but instead will spawn a container which includes qmake, and then call the qmake inside the container. The container part is this yellow part here. On the target, then you also run a container which, as said before, includes GDB server, SSHD, and all the Qt libraries where you link against. So how does this look like if we have a closer look on both containers? So the development container, in our case, runs on an AMD 64 machine, and we want to compile for the target platform, which is ARM HF based. What we want to do is we want to cross-compile, because cross-compiling is much faster than if we would just do an emulated compilation. We could do that as well. So here I separated blue and green. The green parts are basically AMD 64 programs. The blue parts are ARM HF programs or libraries. The nice thing about Debian, which we use in this example, is that you have multi-arch support. So that means you can install our AMD 64 libraries parallel to ARM HF libraries. And then you can compile with a cross-compiler for ARM HF by just linking against the ARM HF libraries instead of the AMD 64 libraries. The qmake is a little bit special in this example. You have to run the ARM HF qmake even on the AMD 64 machine, because else it would generate make files for AMD 64, which doesn't work. However, the nice thing about newer distributions is if you just want to execute an ARM binary, it will automatically detect, the kernel will automatically detect that and then launch it with support, QEMU support, so it will emulate that binary. That's possible thanks to BinFMT. On the target, you just install your Qt package, Qt libraries, and then for debugging as well, open SSH server, rsync, and GDB server. But that will all run natively on ARM HF. Okay, I was talking before about wrappers, so we cannot, because Qt Creator is not aware of any containers, we cannot just tell Qt Creator to use a certain container to compile an application. Instead, we have to write a wrapper which then abstracts the whole container handling. And here is an example for make. Instead of just calling make, we spawn a container with Docker run, and then inside the container will execute the real make, and then it will just, for Qt Creator, be transparent. It doesn't care if it's really in the container or not. We documented that. I put some links in there. There is also a really nice tutorial for CMake, which works almost the same as these examples, from Burkhard Stubert at embeddeduse.com. So you can also have a look there. But then it's for CMake and not for QMake. Okay, then we can already step into the demo. I made a short demo on an Apalis IMX6 processor, running on top of Toradex Core, which is the operating system we are currently developing, which already includes a Docker engine. So the first thing we need to do is we now need to start Weston. Weston is a compositor which then displays the Qt application. We fetch this Weston container from our Horizon feed from Docker Hub. And you can see now Docker is running on the target system. The second screen was basically already running on the target. If we check all processes on the host system, we can see that we see all processes. So we see also stuff that is running inside the container plus everything that runs on the host system. If we now start the Qt develop the target container, then we need to do some port forwarding for SSH and the GDB server, as well as we have to set some C groups so that we can access the GPU. Now, if we run PS again inside a container, then we will see that we cannot see the host processes. We only see the ones that are inside, spawned inside the container. And one of the most important ones for Qt Creator is SSHD, which allows then Qt Creator to connect to the target. So now we are basically ready to set up the Qt Creator. For that we need to define a kit. We call this kit Qt5 Horizon. We select the device, and then we select a GDB multi-arc for debugging, and we define a QMake version, which is basically our wrapper. So instead of having a real QMake running, we just call a wrapper, and this wrapper will then call QMake inside a container. And the point is, Qt Creator, when calling QMake, will do a query on it, which is shown here, and we need to prepend this query a sysroot directory so that Qt Creator can access header files and so on to do some syntax highlighting and to do syntax checking. So that's just required for QMake. Besides that, we just can run the Docker run as shown in the previous slides. And then the device, we have to configure it a little bit special because we do some port forwarding, so we just have to consider that as well when setting up the device. Now that we have configured Qt Creator, we are ready to go. We can now start a compilation, which takes some time. And if you now call make, for example, then it will not call the real make, it will call the wrapper script. And the wrapper script will spawn a container and call make inside the container. This is basically what happens here now. And you can see it uses now the cross compilation ARM HF GCC or G++ instead of the native one. Now we are basically done. We have a binary compiled to the application, and now we are ready to debug. So we can do that as well. We can debug C++ application as well as QML applications. This is running now. It takes a while because it will call qmake and make again, but it shouldn't take too long. So now we already hit the breakpoint in C++. We can do step over, step into if we want to do that. We can continue. And then what we see here is now it's using Wayland EGL. That's the plugin which is used to communicate with the best and compositor, which we see here now. So it uses Wayland EGL to render the image or the application. And if we click now on, then we see we can also debug QML applications. So that's about it from the demo. Then we come to a summary. What are the pros and cons of using Qt or containers in general for development? The nice thing about the containers are that you can pack dependencies together. So that's nice if you work with embedded devices as well if you work on desktop machines. You can have different versions of libraries running in different containers. So you can use Qt 5.2 and 5.12 in parallel if you need to do that. You have some kind of user space isolation, so that an application running in one container cannot necessarily access an application in a second container. And you can restrict device access. You can even restrict memory sizes, CPUs. That's all due to C groups. And creating SDKs is similar to creating images. So if you are familiar with Yocto, it can be quite hard to understand what you do there. With using a container, it's normally just using a distribution, and you write that into a file. The negative thing is that you need more space for doing that, because you have, of course, more than one root file system available, and it's tricky to access some devices because you have to take care about C groups and C group access, and then you don't have the startup dependencies. That means because no init system is running, you have to take care about launching all applications manually. So TPAS, network manager, and so on, what you need. The other not so nice thing today is that Qt Creator doesn't natively allow container usage, so what you have to do is you have to write these wrapper scripts. However, also my colleague Walter wrote a plugin for Visual Studio Code, which you can use to develop with containers, and then it's more a native feeling, and it integrates nicely with the IDE. But not Qt Creator nowadays. Okay, that's it from my side. Thanks a lot for your interest. If you want to check some stuff back, then you can use our Developer Center, or also I put the wrapper scripts on GitHub. And now it will be time for questions.